There's a lot of information out there about how to write good tests, but unfortunately, it really depends on the circumstances. What I can do is show you an example of a bad test and then a good one. I stay with my isOdd function. Currently, my tests involve hard-coded values, 3 and 2. Wouldn't it be a better test to use a random integer out of, say, a million? Of course, I need to know if the random value is odd, so I figure that out. Then I can write my assertion, comparing the return value of the isOdd function with the expected result. The test passes. In fact, I can run it again and again, and even with a random value, it passes. Can you identify the problem? I'll give you a moment. Okay. Of course, the test always passes. The assertion tests the exact implementation of the isOdd function. It's not actually testing anything. Randomization in testing is not unheard of. It presents extra challenges, though, and you have to be specific about your goals. No, the issue is this. Don't reproduce implementation details in your tests. What if the implementation changes? It makes your tests brittle, or, as in this case, useless. Okay, here's an example of a good test. Instead of testing implementation, I strive to be thorough. So far, my tests use positive values as arguments. So I add another test, this time with a negative number, and the test fails. Why? Because a negative integer mod 2 is -1. The results of a good test show that I need to change the isOdd function to account for negative values. I rerun the tests, and now they all pass. You can get more reliable results if your testing is more thorough. Go as far as your code needs. Testing this isOdd function can be even more thorough. Consider decimals or values that are not numbers. Give it a try.